All right, guys, let's take a look at section 12.1 here today. Last chapter for geometry. So by now we should know what parallel planes are. You know, a couple planes like the ceiling and the floor that will go on forever and never touch. And intersecting planes like the ceiling and the front wall where they are going to touch along an edge. Okay. We're going to look at isometric views of three-dimensional figures. If you've had some drafting, you will have seen this before. Kind of a view that's going to make it look three-dimensional a little bit. In your resources, I've added some isometric dot paper that you can use for some of these problems, okay? Investigate cross sections of three-dimensional figures. So if I were to cut across it and then look at that shape, what, you know, is it a triangle, is it a rectangle? It depends upon the shape we start with, of course, but that's what I'm getting at. So isometric view, you're going to have dot paper. Your angles come away at I think 30 degrees to get isometric views from that, and we'll see that in a second. So cross sections, you're cutting across a figure and then seeing what kind of shape it takes on. So use isometric dot paper to sketch a triangular prism, 6 units high. Again, a prism has two congruent segments that are parallel, or shapes that are parallel, triangles, rectangles, squares, etc., with bases that are right triangles with legs 6 units and 4 units long. So here's how we're going to tackle this. Okay, we're going to start by marking the corners of the solid, and then we're going to draw a 6-unit segment down because that's going to represent the height. And then we're going to draw in that 6x4 rectangle. So start somewhere on the page, draw in a 6-dot long segment representing the height. And then I need a right triangle, and if we go off, I was misspoken before. I think these go off at 45. So if I go 4 dots this way and 6 dots this way, I've got my right triangle at the top. And then I just need to button it up. So if I go 6 units down from each of these, I'll represent the height again. And finish off my triangle. Okay, that finishes off the triangle. And then I'm going to draw my 6-unit heights in there. And then I just need to finish off the triangle on the bottom. I need to draw in my sides. And then you'll notice in the back here in a second that we're going to have a dashed line. That simply means it's a hidden view. If I were to look at this, an actual three-dimensional figure from there, I wouldn't be able to see that edge. So we're going to draw it in as a dashed line. Okay? So in the homework, I'm going to ask you to sketch a couple of those. Make as many copies of that dot paper as you need to do that. Okay? So which of these diagrams would show a rectangular prism 2 units high, 5 units long, and 2 units wide? Think about that for a second. Well, let's go through here. This one clearly 1, 2, 3, 4 dots high. That is not 2 units high, so I can eliminate D. Okay, these ones all look like they're 2 dots high. Okay, and then it's supposed to be 5 long and 2 wide. So this one's 5 dots. This one's 1, 2, 3, 4, 5 dots. This one's 1, 2, 3, 4, 5, 6, 7 dots. So that one's too much. So now we're rounded down, narrowed down to these 2 guys. And then it's supposed to be 2 wide. This one's 1, 2, 3 wide. This one's 2 wide. Looks like it's got to be C. Okay? All right. Use isometric dot paper and the orthographic drawing to sketch the solid. So now, what does this look like if you're looking at it from the top or the front? So let's think about this. From the front, you're seeing 4 columns, 2 high, 3 high, 2 high, 1 high. So you've got that kind of weird building shape here. But from the top, it just looks like an L, which means it's not as deep as we think it needs to be. And we're going to take you kind of through those views. So the top view indicates 1 row of different heights and 1 column in the front row. So you got 1 row, differing heights, because you see some solid broken lines here, and then that 1 column in the front row. The front view indicates that there are 4 standing columns. Okay, this view right here. The first column on the left is 2 blocks high, followed by 3, followed by 2, followed by 1. Okay, the dark segments indicate breaks in the surface. The right view indicates that the front right column is only 1 block high. The dark segments again indicate breaks in the surface. Okay, the left view indicates that the back left column is 2 blocks high. Draw the figures so that the lowest columns are in the front and connect the dots. So if you're looking at it from this side, you can see 2 high, 3 high, 2 high, 1 high, just like the right view, okay, or the front view. From the right side, if you're looking at it here, you can see 1, 2, 3 high, and then 1 high in this first column. From the top, it's gonna look like 1, 2, 3, 4 wide and 1 column jutting out. So this is kind of what you're looking at. That isometric dot paper will help you with that as well, okay? So what do you think? So if this is your shape, you've got top view, left view, front view, right view, which one are we looking at here, okay? So front view, I'm seeing 3 columns high, 2 columns high, okay? 3 columns high, 1, nope. 3 columns high, 1, nope. 1 column, then 3, then 2, nope. 3, then 2. This is it. We kind of narrowed it down to this one already, but then you can see the other views if you want as well. They should match in there. You know, the right view is 3 high, then 1 high. The top view looks like a box because we've got 2 by 2 shaded at the top there, okay? All right, how about this one? Now we're getting into cross sections. Customer ordered a 2-layer sheet cake. Determine the shape of each cross section. So I could cut it this way, like across the middle, or this way. And because it's a rectangular prism, you know, if I cut it this way, that shaded area is going to be a rectangle, and if I cut it this way, it's also going to be a rectangle, okay? Not the same dimension rectangle, but they're rectangles nonetheless. Okay, so what do you think here? A solid cone, think of an ice cream cone, is going to be sliced so that the resulting flat portion can be dipped in paint and used to make prints of different shapes. So you're going to do a cross section, dip it in paint, and then put them on the wall to make those shapes. How should the cone be sliced so that the prints are in the shape of a triangle? Okay, well, what you need to do there is cut from the perpendicular to the base through the vertex. So from the pointy part of the cone straight up. And then if you look off to the side, you're going to get that nice triangular view. Okay? All right, you guys, so pretty small assignment, page 841, 9 to 27 the odds. Good luck.